When I differentiate, my second derivative is nothing but d square y divided by dx square. That's nothing but dz by dx. Second order derivative is x into z square minus y square. If I want to consider second order derivative, then d square y divided by dx square, that is nothing but dz divided by dx. Hello to all, a warm welcome to my new session on third unit, and the chapter name here is Ordinary Differential Equations. I am your Revati ma'am, faculty from the Department of Computer Science, Vidhyaashram, first grade college, the Temple of Excellence, MYSURU. So dear student, in my last session, I started with Taylor series method and I have solved some of the example problem. But in my today's session, I'm going to deal with Range-Kutta order 2 method. In the sense, I'm going to use Range-Kutta second order and I'm going to solve some of the example problems. Now, let me to discuss the formula. So, dear student, in Range-Kutta order 2 method, we are going to have two formulas, or I can able to follow two methods. And if I go with first method, I'm going to get the answer. Even if I go with second method, I'm going to get the answer. So I can able to use method 1 or method 2, and it is completely left to you. In the sense, which method you feel easy, you can able to use that method. Now, in Range-Kutta order 2, and if I consider method 1, I have to find out K1. So, to find out K1, I'm going to have the formula H. H is nothing but the height. And I'm going to have f of x naught comma y naught comma z naught. So dear student, here I'm going to consider the function, and if I consider f, there is nothing but the first order derivative, and if I consider g, then it is represented as second order derivative. Anyway, I'll explain what is first order derivative and what is second order derivative while solving the example. For time being, you just remember only this formula. Okay, now I want to find out L1. So what is L1? That is nothing but H into g of x naught, y naught, z naught. So it is nothing but this second order derivative. And I'm going to find out K2, which is nothing but height into function. See, x naught plus height, then I'm going to consider y naught, and I'm going to consider K1 and z naught, which is nothing but the L1. So z naught plus L1. Now, to find out L2, once again, I'm going to consider the second order derivative, that is g. So, x naught plus h, y naught plus k1, then z naught plus L1. Now, what is y1? y1 is nothing but y naught plus k1 plus k2 divided by 2. Anyway, dear student, while solving the problem, I will explain how to find k1, L1, k2 as well as L2. Now, dear student, let me to consider second method here. So, k1 is nothing but hf. See here, both the functions are same here. Okay, so if I consider first method or second method, the formula used to find out K1 and L1 same. And see here, the formula is going to change only when I want to find K2 as well as L2. So here, height into function x naught plus h divided by 2, then y naught plus K1 divided by 2, then Z0 plus L1 divided by 2. And here also see here, that is L2 equal to Hg X0 plus H by 2, Y0 plus K1 divided by 2 and Z0 plus L1 divided by 2, and Y1 is nothing but Y0 plus K2 plus K1. So what is Y1? Y1 is nothing but Y0 plus K1 plus K2. And if I consider previous methods, here it is divided by 2. But here I am not having divided by 2 because I am going to divide each term here. For that reason, I am not going to divide by 2. Okay, these are the two methods used to find Range-Kutta order 2. Now, let me to consider the example here. See, find y of 0.1 for y double dash equal to, y double dash in the sense what? Second order derivative. 1 plus 2xy minus x square z, comma, x0 is nothing but the 0, y0 is nothing but 1 and z0 is nothing but 0. And what about h? H is nothing but 0.1, and using Range-Kutta method, I want to solve this problem. So dear students, see here, in the solution given y double dash equal to, so this is nothing but my function, and y of 0 is 1, y dash of 0 is 0 and h is nothing but 0.1 and y of 0.1 I want to find out. So what is y of 0? That is 1 and x of 0 is nothing but 0. Now see here, dear student, I have x term, y term as well as z term. So what I will do, first I will consider put dy divided by dx, that's nothing but this z. So this is nothing but my first term, okay. And differentiate with respect to x. And when I differentiate, my second derivative is nothing but d square y divided by dx square. That's nothing but dz by dx. Now see here, when I have system of equation, here my first derivative is nothing but dy divided by dx, that is nothing but this z, that is nothing but function of x comma y comma z. And if I consider dz divided by dx, so this is my second derivative, then I'm going to have the function. So what is the function I got in my question? Okay, that's nothing but g of x comma y comma z. Now see here, I'm going to use first method. So what is the formula I have? So here formula is K2 HF x0 plus h and y0 plus k. Okay, now see here. If I consider the Range-Kutta order 2, then I'm going to find out K1, L1, K2 and L2. So here K1 is nothing but height and function. And if I consider the question, what is the height? H is nothing but 0.1. So I'll write 0.1. And what about x is 0, y is 1 and z is 0. Okay, so 0, 1, 0. And if I multiply, I'm going to get the answer 0. Now see here, I want to find out L1. So here L1 is nothing but height into g. That is nothing but the second order derivative, in the sense I want to consider the function which is specified in the question. So I want to consider the question, okay, and whatever the equation I have, that's nothing but the g of x naught, y naught and z naught. So here once again 0, 1, 0, and I want to substitute these values in the equation. So what is the equation? 1 plus 2xy xy minus x square into z. Okay, and when I substitute all the values in this equation, I'm going to get the answer 0.1. Now I want to find out K2. So here K2 is nothing but HF of, I want to consider x naught plus h, comma y naught plus k1 and z naught plus l1. And when I substitute all the values, I'm going to get the answer 0.01. And if I consider L1 equal to h into g. So here g is nothing but the function. Okay, so what is the function? This one. So 1 plus 2xy plus x square into z. Okay, then I want to take x naught plus h, y naught plus k, z naught plus l. So what is x naught? 0 plus 0.1. Here 1 plus k1 is nothing but 0. Then z is nothing but 0 plus l1 is how much? 0.1. So g of 0.1, then 1, then 0.1. Okay, and when I substitute these values in this equation, I'm going to get the answer 0.1199. Now I want to find out y1. So y1 is nothing but y naught plus k1 plus k2 divided by 2. So what is y naught? Y naught is 1. Fine. And what is k1? K1 is 0 plus k2 is nothing but 0.01 divided by 2. So the answer is 1.005. So when y of 0.1, what is the answer? 1.005. Now, dear student, let me to consider another example here. Find y of 0.2. Okay, I want to find out y of 0.2 for y double dash equal to xz square minus y square, where given x naught is 0, y naught is 1 and z naught is 0. With step length. So what is h here? H is nothing but 0.2 and I want to use Rangekutta order 2. Now the solution here is given second order derivative is x into z square minus y square. And what about y naught is 1? Then x naught is 0, h is nothing but 0.2 and I want to find out y of 0.2. Okay, now see here, z is nothing but dy divided by dx and it's used to obtain second order derivative d square y divided by dx square, that is nothing but dz divided by dx. We have system of equations, that is dy divided by dx, that is equal to z, that is equal to function of x comma y comma z. So what is x? 0. What is y? 1 and z is 0. And what about dz by dx? That is nothing but the equation. Okay. So dear student, now I want to find out second derivative, that is nothing but dz divided by dx. So dz divided by dx is nothing but x z square minus y square. Now, dear student, I'm going to have the Rangekutta method order 2. That is nothing but Rangekutta order 2. Then the formula here is K1 equal to HF of X0, Y0 and Z0. So here 0, 1, 0. Okay, and what about height? Height is nothing but 0.2. So I'm going to get the answer 0. Now, dear student, if I consider L1, here I want to consider second order derivative, that is nothing but xz square minus y square. Okay, and once again I have 0, 1, 0. Okay, and when I substitute the value, I'm going to get the answer minus 0.2. Now, dear student, I have K2. In the sense, I want to find out K2. To find out K2, I'm going to have the formula H f of x0 plus h, y0 plus k1, z0 plus l1. Okay, so here I have the value x0 is 0 plus 0.2, then y0 is 1 plus k1 is 0, then z0 is 0 plus l1 minus 0.2. So it is 0.2, 1 minus 0.2. Okay, and I'm going to get the answer minus 0.04. Now, if I consider L2, that is nothing but Hg. So here G is nothing but second order derivative, in the sense I want to consider the function. So here once again I have 0.2 into G of 0.2 comma 1 comma 0 minus 0.2. Okay, when I substitute these values in this equation, I'm going to get the answer minus 0.1984. And when I substitute all these values in this equation or in this formula, I'm going to get the answer 1 minus 0.02, in the sense y0 is 1 plus k1 is 0 plus k2 is nothing but minus 0.04, k divided by 2, that is nothing but 1 minus 0.02, which is nothing but 0.98. So dear student, when y is 0.2, I'm going to get the answer 0.98. Now, dear student, let me to consider another example here, that is find y of 0.14 y double dash, that is nothing but minus 4z minus 4y, and y not a 0, x naught is 0 and z naught is 1. In the sense y naught 0, x naught 0 and y naught is 1. Then what about h? H is nothing but 0.1. And I want to solve this problem by using Rangekutta order 2. Okay, now see here, I want to find the solution. So given equation is nothing but minus 4z minus 4y, and y naught is 0, x naught is 0 and z naught is 1, and h is nothing but 0.1, and I want to find out y of 0.1. Okay, see here, I have first order derivative, that is nothing but dy divided by dx, that is nothing but z. Now, if I want to consider second order derivative, then d square y divided by dx square, that is nothing but dz divided by dx. So here first order derivative is nothing but z. Z is nothing but f of x comma y comma z. And if I consider second order derivative, that is nothing but my function or my equation, that is represented as g of x comma y comma z. Now I want to apply Range-Kutta order 2. So here I'm going to have the formula K1, L1, K2 and L2. So order 2, for that reason I have only K1 and K2. Fine. Now what is H? H is nothing but 0, 0.1 and X naught is 0, Y naught is 0 and Z naught is 1. Okay, so here I'm having 0.1 into 1, that is nothing but 0.1. Now L1 is nothing but H into G. So here G is nothing but minus 4Z minus 4Y. Over. So here once again 0, 0, 1. 0.1 into Z is 1. So I'll get minus 4. So when I multiply, I'll get the answer minus 0.1. Now dear student, I want to find out K2. K2 is nothing but height into function. So here 0 plus 0.1, 0 plus K is nothing but 0.1, Z naught is nothing but 1 plus minus 0.4. So I'm getting answer 0.1, 0.1 and it is 6. That is 1 minus 0.4. So when I multiply, I'm going to get the answer 0.06. Now dear student, I want to find out L2. So L2 is nothing but height into second order derivative. So here it is 0.1, 0.1 and it is 0.6. Okay, fine. And when I substitute these values in this equation, I'm going to get the answer minus 0.28. Now, y1 is nothing but y0 plus k1 plus k2 divided by 2. So, what is y0? Y0 is 0. So, here y0 is 0 plus k1 is nothing but 0.1. Then what about K2? That is 0.06 divided by 2. So the answer is 0.08. Therefore, y of 0.1, the answer is 0.08. Anyway, dear student, in my today's session, I started with Range-Kutta order 2 and I have discussed two kind of formula used to solve Range-Kutta order 2. But in my next session, I'm going to deal with Range-Kutta order 4 with some example problems. Anyway, dear students, let's meet in the next session with the new concept, that is Range-Kutta order 4 with some example problems. Until that, keep watching and keep learning. Thank you.